Next, we're going to try to bring a visual component to limits as well. What I'd like to do is sketch the graph of a function with the following aspects. So I've given you both some function values as well as some limits that are going to exist on this graph. So the limit as x approaches 3 of f of x is equal to 2, but f of 3 is going to be equal to 4. The limit as x approaches negative 2 from the left of f of x is equal to 3, but the limit as x approaches negative 2 from the right of f of x is going to be equal to negative 1. Now, any place where the limit exists but is not necessarily equal to a function value, typically that's going to manifest itself on a graph as an open circle. Open circle means you can go up to but not actually touch this particular point. So let's consider what's going on at x equals 3 first. So here's x equals 3. We'll draw in a couple of y values as well. So if we actually plug in x equals 3, we're supposed to get positive 4. So on a graph, that would simply be a point at the ordered pair 3, 4. However, for the limit to be equal to 2, that is the two-sided limit to be equal to 2, that means that there would be an open circle at 3, 2, and the function would come out on both sides. So the function approaches this open circle, but we actually get a closed circle up at 3, 4. Now on the other side, at x equals negative 2, when we approach negative 2 from the left-hand side, we're supposed to get positive 3 from that. So at an x value of negative 2, the graph is approaching positive 3. So positive 3 is up here. Now this is only as we approach from the left side. So I'm going to extend this function out to the left side. Whereas when we approach negative 2 from the right-hand side, we're going to be approaching a function value of negative 1. So as x approaches negative 2 from the right side, the y value is approaching negative 1. So this will extend out from only the right-hand side. Now, as soon as you have all of these things graphed, now it's a matter of connecting the dots. And what I like to do is go from left to right across. So the first point of significance happens at x equals negative 2, right here. So considering to the left, we'd have to be up at this point here. Now, I haven't specified what the function is supposed to be doing to the left of that, so I can basically draw it however I want. Now, extending from negative 2 and going to the right, the next important thing that I'm supposed to approach is this open circle right here because of this part of the graph. So I'm going to connect this part of the graph to this part of the graph, and again, it doesn't really matter how you do so, as long as you're obeying the vertical line test to make sure that we're working with a function. Then once we hit x equals 3, we've got our closed point up here, but then the graph is supposed to extend from this point and keep going. And again, I haven't specified what's supposed to happen to the right of here, so I can draw it however I want as long as it obeys the vertical line test. Now, my favorite answer to this that I have ever seen before is a student responded with the following, which means that they opened up to the back of the book, they copied down the answer, answers will vary, and then just called it good. So don't be that student. Be the student that actually sketches me a graph. That'd be awesome.